Today we're going to be solving a different type of balls and boxes problem. So, so in the previous videos we were dealing with problems that involved distributing identical balls into distinct boxes, but in this video we're going to be distributing distinct balls into distinct boxes. Now, how will we do that? So, in the previous videos, I gave you equations that you can use to insta-solve these kind of problems. But in this video, in this topic, I'm gonna be showing you a three-step method that comes really handy and really elegantly and easily solving these kind of problems. So the first step is number separation of balls into boxes, and the next step is to order the boxes and then distribute the balls. So probably these steps will seem pretty confusing to you guys because, firstly, step 1 and step 3 kind of sound like the same thing. But as we solve this problem, you're probably going to get an idea of what each of these steps mean. So let's read the problem first. So the problem says to find the number of ways of distributing 8 distinct balls into 3 distinct boxes such that each box contains at least 2 balls. Okay. So let's start with step 1 first. Okay, I'll put that in red to show that it's the first step. So we're gonna have our 3 boxes here. So let's just assume. So in this first step, we have to assume that the balls and boxes are both identical. So the balls are identical and the boxes are identical. So the number of ways to separate identical balls into identical boxes, and with these restrictions, with the box containing at least 2 balls, would be to have 4 in one of the boxes, 2 in one of the 2 in one of the boxes, and 2 in the other, or having 3 in one of them, and then 3 in the other, and then 2 in the last one. So it turns out that these are the only 2 ways to do this. So we assume that the balls are identical and the boxes are identical. Now we're done with problem 1 now. We numerically separated the balls into the boxes. Now we have to move on to step 2 where we have to order the boxes. Now this is going to be a little more complicated. So here we assume that the boxes are identical, but now in step 2 we have to consider that the boxes actually are distinct and the order matters. So the ordering of 4, 2, and 2 matters. The ordering of 3, 3, and 2 matters. So this can be 4, 2, 2 or 2, 4, 2 or whatsoever. So here, the number of ways to order these quantities would be 3 factorial, since there are 3 objects, and then divide by 2 factorial as two of these quantities are the same, because we have 2 2's here. So we have to divide by 2 factorial again. And this will give us 3. And same with this. There are 3 quantities to order, but 2 of these quantities are the same. We have 2 3's here. So you have to divide by 2 factorial to get 3 ways. There we go. So we've done step 2 now. But now we have to move on to step 3 where we have to now consider that the balls are distinct. So we have to distribute these distinct balls. So what we have to do here, I'll put this in green. So we have to choose. So let's look at the first case first, 4, 2, 2. So first, we have to consider that. So in this case, we have to choose 4 balls from the 8 distinct balls. We have to choose 4 from 8. So we have to do 8 choose 4. And then after we choose 4 from these 8 balls, we have 4 left. And we have to choose 2 balls from those remaining 4 balls. So it's going to be 4 choose 2. 4 choose 2 times. And then we have to choose 2 balls from the remaining 2 balls, which is 2 choose 2. And this will give us the value 420. There you go. And for the second case, well, the same thing. So we have to choose 3 balls from the 8 distinct balls. So it's going to be 8 choose 3 times. And then we have to choose 3 balls from the remaining 8 minus 3 equals 5 balls, which is 5 choose 3, and then now we have to choose 2 balls from the remaining 2 balls, which is 2, choose 2, equals 560. So what we did here, for example, in this first case, since the balls are all distinct, we just calculated the number of ways to distribute the distinct balls into this kind of system. Here we calculated the number of ways to choose a certain number of balls from the distinct balls to put it in this kind of structure. And same with here. So here we finished all the 3 steps, but we're not done yet. So we have to multiply these 2 values. So 428 times 3, let's put that in black now. 428 times 3. So we have to add, so these are different cases, so we have to add them together. But we have to consider, so here we have to consider the ordering of the boxes and the distribution of the balls, so we have to multiply them together. So 420 times 3, so we have to add 420 times 3 plus 500, so in the second case, 560 times 3. 560 times 3, and this will be equal to, so 420 times 3 is 1260, plus 560 times 3 is equal to 1680. And if we add these 2 values, we're gonna get the answer 2940. And that is our answer. So there you go, we just solved this problem. So to summarize this, so for these kind of problems where you distribute distinct balls into distinct boxes, so the first step you have to assume that the balls are identical and the boxes are identical, and just separate the balls into those boxes numerically. So then after that, so you have to consider that the boxes are distinct. So you have to consider that the ordering of the boxes actually matter. So you find a number of ways to order the quantities. So like we did here. And then after that we have to consider that the balls are all distinct. And then find the number of ways to distribute those balls into this kind of structure, into the structure you made in step 1. So that's how you do it. So yeah, this is a really useful method for solving these kind of problems where you distribute distinct balls into distinct boxes. And yeah, hope you enjoyed this video, and see you in the next video.